This video goes over how to solve rational inequalities. So the first thing that we have to do always is to make it less than or equal to 0. So we're going to simplify that by moving the 1 over onto the left-hand side and then finding a common denominator. Really what we are doing is we are creating a rational function, and then we're going to examine the vertical asymptotes and x-intercepts because those are the only place that a function can change signs. When we did polynomial inequalities, we only had to look at the x-intercepts. Now we also have the vertical asymptotes. So I'm going to move over the 1, and then I'm going to create a common denominator by multiplying 1 by x minus 3 on the top and on the bottom, which means I'm now looking at x minus 1 on the top, or 7 minus x, excuse me, on the top, over x minus 3 is less than or equal to 0. So to get my vertical asymptote, I'm going to look at the zeros of the denominator, which are just 3. And then I'm going to look at the zeros of my numerator for the x-intercept, and that is 7. So those are the only two spots that my function can change signs. So on my number line down here, I'm going to put on x equals 3, and I'm going to put on x equals 7. That splits my region, my x line, into 3 separate sections that I have to test. So the first thing I'm going to do is I'm going to test a value that's to the left of 3. I'm going to test a value that is in between 3 and 7. And then I'm going to test a value that is to the right of 7. I'm going to use the same approach for the charts that I did with the polynomial functions. And I'm going to put 7 minus x, and then x minus 3, and then overall, I'm investigating the sign of my function. When I put in 0 to 7 minus x, I'm going to get a positive value. When I put in 0 to x minus 3, I'm going to get a negative value, which means that overall my function is negative. When I put in 4 into 7 minus x, I get a positive value. I also get a positive value in between for x minus 3, which gives me an overall positive value for my function. The next value that I'm going to put in is 10. 7 minus 10 is a negative value. 10 minus 3 is positive. So overall, my function is negative. If it helps, what I can do is I'm going to add some things here. So x equals 3. This is a vertical asymptote. So I'm going to use an open circle to represent that. And then I can actually use my intervals. I can label my intervals to make it easier for me to interpret my intervals that satisfy my inequality. So where I've written x equals 0, this is actually going to be the interval from minus infinity all the way up to, but not including 3 because that is my asymptote. In the middle here, this is 3 to 7, including that value because that's an x-intercept. And then on the right-hand side, I've got 7 to positive infinity. Now I'm going to go back up and check. I've written including because I can actually get that value, but my inequality is less than 0, which means that even though I can actually put in that value, I'm not going to get there because that's where my function is equal to 0, not less than 0. And then I can see that my function is less in these two intervals, which means that my solution for x is, I would say that x is an element of minus infinity to 3, which is my first region, as well as 7 to positive infinity. So let's try another example. Here, you should notice that right away we're going to have to factor both of these. And so I'm going to factor the top as x minus 4, x plus 1. And I'm going to factor the bottom as x minus 2, x minus 3. I'm looking for the values where it's greater than or equal to 0. So my vertical asymptotes, those are from the denominator. Now that I've factored it, it's easy to see those ones. X equals 2 and x equals 3. My x-intercepts, those ones are from the numerator. So I've got x equals -1 and x equals +4. So I've got a lot of values to put on my number line. This time my inequality is greater than or equal to. So I'm going to use closed circles for my x-intercepts, and I'm going to use open circles for the vertical asymptotes. So the first one that I'm going to put on is -1. That's my smallest number. I'm going to use a closed value because that is an intercept. My next one is 2. That is a vertical asymptote. So I'm going to use an open circle. Then I'm going to use an open circle for x equals 3 because that's also a vertical asymptote. And then I'm going to use a closed circle for x equals 4. Down on the left side, now I've got 2 things to consider. I've got the numerator and the denominator. So I've got x minus 4, I've got x plus 1, I've got x minus 2, and I've got x minus 3. Overall, looking at the value of my function. Above my number line here, I'm going to put my regions. So I've got minus infinity all the way up to and including -1 because I can get it equal to 0. Then my next one is from -1 to 2, not including because that's an asymptote. Then I've got in between 2 and 3. Then I've got in between 3 and 4, including 4. And then finally 4 to positive infinity. So I'll go through and put in my test values here. -2 in this region, 0 in the next one, 2.5, and 3.5. So in those values, when I put in -2, I'm going to get a negative number, a negative number, negative number, and a negative number. 4 negatives overall means that my function is positive. When I put in 0 into each of those brackets, I'm going to get a negative, a positive, a negative, and then a negative. An odd number of negatives means that I'm going to have a negative value overall. Subbing in 2.5, I've got a negative, then a positive, then I have a positive and a negative, which means that I have another positive interval. When I put in 3.5, I still get a negative here. Then I get a positive value here. Then I get a positive value here. And then another positive value here, which means overall my function is negative. In my last interval, 4 to infinity, I can substitute in 5. 5 minus 4 is a positive number. 5 plus 1 is positive. 5 minus 2 is positive, and 5 minus 3 is also positive. So that means that my function is also positive. The intervals that I'm looking for are the positive ones. So that is this one, this one, and this one. So then I can say that my x is an element of -1 to minus infinity, 2 to 3, and 4 to positive infinity. And the last example on the skeleton note we will do together in class tomorrow.